To find the net force in, for example, case 1, we just simply need to find the components of each of these um, forces. For F1, in the first case, we have that F1 only has a component in the x-axis and it is in the negative part. So it will be the magnitude. The vector then is the magnitude in the direction minus x. Newtons in the x position. We're going to call it better just with the x unit vector. Now, for the force 2, the vector is only in the negative part of the y-axis. So we'll have minus the magnitude, which is 16 newtons in the j, with the j, or I'm going to put it better, the y unit vector. Now, having this, we just need to obtain the net force. So the net force is just the sum of these two. Because we got the net force is just simply the sum of these two forces. So we will have minus 10 newtons in the minus and minus 16 newtons. Now, to obtain the magnitude of this, we simply need to take the square root of each of these components to the square. Minus 10 to newtons squared plus minus 16 newton squared. And this is equal to 19 newtons. We can also obtain the angle of this net force because is the tangent, the minus tangent of the F net, the y part over the x part. So putting that in here, we'll just simply obtain that this is 10.2, sorry, 16 because that's the y part, 16 newtons over 10.12 newtons. And this will give us a value of 57.88 degrees. We can see that when we are summing these two forces that are in the third quadrant, which is in here, so we have these two, this was F1 and this was F2. So the resultant force vector should be in here. And the angle that we have obtained is this angle, but this angle is with respect to the minus x-axis. If we want the angle with respect to the x-axis, the positive x-axis, we need to add this angle in here, which is 180 degrees. So the angle is, let's see, plus 180 degrees. And this will give us a value of 237.5 degrees. This is the angle of the net force. Now, we are also asked to find the acceleration. So the net force is equal to the mass times the acceleration. So if we find the acceleration, we just simply divide the net force over the mass. In this case, the net force is this value, 19 newtons, and the mass of the object, in this case, we are given that that is 18.5 kilograms. This will give us a value for the acceleration of 1.027 meters per second square. So this is the acceleration. This is the force, the net force, the magnitude of the net force, and this is its angle with respect to the positive x-axis. Now, for part B of this problem, we do similar steps. We start by finding the components of each of these functions, of these forces. Sorry. From here, we can see that the angle in here is 90 degrees. So 90 degrees, 120 minus 90 degrees will give us that this in here, this angle in here measures 30 degrees. So with that in mind, we can find the components of each of these. We're going to put it in here to see it better. So F1 is equal to the vector is equal to the x component will be this the magnitude times the cosine of 30 degrees. This will be newtons in the x component. And it is positive because it is pointing to the positive x-axis. This minus because it is pointing to the y, the negative y-axis. This is minus 10.2 sine of 30 degrees newtons in the y-axis. And for F2, for the force 2, is easier because we only have a y component, which is positive and which is 16 newtons in the y part, positive part. So having that in mind, we just simply sum for the net force equal to the sum of these two vectors, which is 10.2 cosine of 30 degrees and newtons in the x part. Now we can see that we can subtract the y part of the first force and the y part of the second force. So we will obtain that this is equal to 10. I'm going to introduce this value in the calculator to have it in a better. So 10.2 times cosine of 30 gives us a value of 8.83 newtons in the x bar, and resting the other two will give us plus 10.9 newtons. Now, we can find the magnitude of this net force to be just the square, the sum of the square of these two components. And this gives us 14.03 newtons. And we can also find the theta, tangent minus 1, and this is 10.9 over 8.83, and this gives us 50.1 degrees. And in this case, I'm sorry, this is 51 degrees. So we obtain the net force and the angle with respect to the x, the positive x axis, and the final thing to find is the acceleration, so that we know the same, that the net force is equal to mass times the acceleration. So solving for the acceleration, we have the net force over the mass. In this case, the net force is 14.03 newtons times the mass, which is 18.5 kilograms. And this is equal to 0.76 meters per second squared. So this is the acceleration for part B of this problem. This is the net force, the magnitude of the net force for this part, and the angle for the vector of the net force.